My name is Utkarsh. I work as a software engineer at Google Music.
Okay, yes. Hi, class. Very good morning, everyone. Very good morning, everyone, and welcome to the session. Yes, good morning, Ashutosh. Good morning, Pradeep. All right. Very, very good morning, everyone. Come on, let everybody join quickly. And this is the another next practice session on for the upcoming BARC 2025 examination. All right. Yeah. So let's get moving ahead. Seems audio video fine. Okay. Yes, guys. So just the next weekend, that is 8th and 9th of March, the BARC 2025 examination will be conducted. And we had one practice session on control systems. This is the next practice session that is on signals and systems. Okay, the next practice session that is on signals and systems. Okay. Let's get moving ahead. All right. Yeah. So starting up the session, guys, and before that, an important update that yes, for all the future aspirants of GATE, if you want to prepare for GATE 26, 26, 26 or 27 and opting for any of the online courses of OHM Institute, OHM Institute brings to you the OHM online scholarship test. Yes. Okay, wherein, by your performance in the scholarship test, you can avail huge scholarships on all the online courses. Just a moment. Right. Okay, so this next OHM online scholarship test will be held on the March of 23rd. Okay, March 23rd, 2025, which falls out to be a Sunday, and you can appear in the examination. The timing will be evening 6:30 p.m. to 7:20 p.m. The syllabus is mentioned for EC and EE, and if you score and if you perform in the top three, if your rank is in top three, you get 100%. That is your entire course fee waived off. If you are in the rank 4 to 10, you get 50% scholarship and etc. based on your performance. Scholarship has been mentioned here. Right. So yes, guys, if you want to register, there is also a registration form attached in the description of the video, so you can directly go and click there, or you can directly go to our website. Okay, ohminstitute.in. Okay, and there itself the test will also be conducted, or you can also go to download our app OHM Online Plus. Right. Good morning, random. So guys, now starting up with the first question of the day. Okay. Starting up with the first question of the day, the output of a system is given to you x0 minus xt, where xt is the input to the system. Okay, now classify the system. Okay, now classify the system. Okay, look into it. It's a simple question basically. It's a simple question only. Okay, yeah, have a look into this one. See, yt is x0 minus xt, or yt is like minus of xt plus x0. X0 is some initial value of the input, but doesn't matter. It is of the form axt plus b. Okay, and a constant term will not make the system linear. This is going to affect the linearity. Okay, so we know that we have studied our fundamentals. Okay, this should be non-linear, but as well as time invariant. It will be time invariant but non-linear. Okay, because non-linear because of this this additional constant term because of that plus b, or the initial condition, I would say x0. Correct? Right. So no, it's not linear, Madhu. It's non-linear. Okay, it's non-linear and time invariant. That means option number D. Option number D. Okay. Moving ahead to the next one. Okay, the complete derivation of this, I've done in my earlier classes, so you can have a look into there. Okay. Okay, let's move ahead. Let's move ahead to the next one. Okay, so there are two systems, T1 and T2. They are cascaded to get the system T as shown in the figure. Okay, as shown in the figure. Okay, so let xn be the input, yn be the output, and the two systems are cascaded to build a entire system T. Which of the following is true? Okay, which of the following is true? Right. Yes, Ashutosh, correct answer for the previous one. Yes, Pradeep, correct answer. It's D for the previous one. Okay. Yeah, random we'll try based on the availability. In some of the batches I'll take also. Okay. So which of the following statement is true? If T1 and T2 are both linear, T is not necessarily linear. Okay, so because it's a cascaded case and this particular output, let's say this is W, will be a function of x power 1 because T1 is linear. Y will be a function of W power 1 and hence ultimately Y will be a function of x power 1 as well. Because if both are linear, Y is a function of W power 1. Further, W power 1 is a function of x power 1. So Y will also be a function of x power 1. That simple way you can conclude, okay, that the system, the combined system will be linear. But if you look into the reverse statement, if both T1 and T2 are non-linear, then T is not necessarily non-linear. Have a look into this example. As I told you, this initial value, if this initial value was not there, if I remove it, then the system is linear. Okay, then the system is linear. Ashutosh has already come up with the correct answer. Yes, see. Okay, see, if this initial value was not there, then the system would be linear also. So what can I do? I can assume a simple scenario here. Okay, let's say that Wn, okay, is equal to, something like xn minus 1. Okay, as an example. Okay, that means T1 is non-linear. Okay, T1 is non-linear. T2. Now T2 means output is W, and suppose that output is Y, input is W. And suppose it is Wn plus 1, but again with some initial value, T2 is non-linear. So both of them are non-linear, right? But then finally, what is the Yn? So now you substitute Wxn minus 1 plus 1. Wn, if you substitute, so what you are finally getting is, okay, for the complete system T, Yn equal to Xn, it is linear, right? So if T1 and T2 are both non-linear, then T is not necessarily non-linear. This is true. It may be or it may not be non-linear. See, if this was minus 2 and if this was plus 1, then a minus 1 will be left. Okay, then it will be non-linear. Okay, so if T1 and T2 are non-linear, the resultant system may be non-linear, may be linear as well. Have you got that? Okay, so correct answer will be option number C. The correct answer will be option number C for this. Right? The correct answer will be option number C. Okay. Right. Okay. So if T1, if you want the explanation for B, if T1 and T2 are both time invariant, then what happens to T? If T1 and T2 are both time invariant, Nadir, okay, that means, see what happens if Xn has the output Wn, you can assume like that. X of n minus 1 will have the output Wn minus 1. Okay, because if T1 is time invariant, the time shift in the input will give the similar time shift in the output. Then for Wn minus 1, output is Yn minus 1. That means for input Xn minus 1, output Yn minus 1, whatever shift in the input, same shift will come in the output even if I solve it in cascade. Okay, so if T1 and T2 are time invariant, T will also be time invariant. Okay, T will also be time invariant. Okay, whereas the option number B says that T is not necessarily time invariant. Got it? Okay, if T1 and T2 are both causal, if T1 and T2 are both causal, causal means what? The input output, the output will depend only on the present or past values. Okay, so suppose W of n, let me take only one past instance, W of n is x of n minus 2. Suppose Y of n, T2 is also causal, na? It also will depend on past or present. I am only taking past for example. So suppose Wn minus 4, but what will be Wn minus 4? What will be Wn minus 4? It will be further xn minus 6, further past. Okay, further past. So that means overall system is also causal only. Okay, so if T1 and T2 are causal, then T is also causal, necessarily causal only. So D is also wrong. Okay. Okay, the C is the correct answer. C is the correct answer. Right? Moving ahead to the next question. Right. Yeah. Here is the next question. An input xn with length 3 is applied to a LTI system having an impulse response hn of length 5. Okay. And y omega is the dtft of the output yn of the system. Y omega is the dtft of the output yn of the system. If modulus hn less than equal to L, modulus xn less than equal to B for all n, then what is the maximum value of y0? What is the maximum value of the y0? Okay. So let's work it out. Okay, xn has length 3. Okay, and impulse response has length 5. Y omega is the dtft of the output yn of the system. So what is the output of the system? In time domain, it is given by input convolution with the impulse response. So if I want to talk about the y omega, if I want to talk about the dtft, the convolution in time is multiplication in frequency, that is x omega multiplied by h omega. That is what we know. Okay, now what is the maximum value of y0? First of all, what is y0? See, what is y0? Right? Y0 is equal to x0 multiplied by h0. x0 multiplied by h0. Okay, but what is x0 or what is y0? I mean, what is the, DC value? Okay, for any Fourier transform at omega equal to 0, if you calculate the value, it is equal to summation of the signal. Okay, summation of the signal, or if it is a continuous signal, it's equal to integral of the signal or area under the signal. Here it is discrete case, so we can call that this y0 is nothing but x0. x0 means summation of xn multiplied by h0, and h0 means summation of hn. Okay, now this is what is y0. Question is asking what could be the maximum value, not only y0, maximum value of y0. Exact value we can't calculate because signal xn and hn is not given, only their length is given. Only the length is given. It's a good thoughtful question. It's a good thoughtful question. So you want to maximize this y0. This will be possible. This will be possible if you maximize the right side. Okay, maximum value of summation hn, maximum value of summation hn. Now, what is xn not given? Okay, but xn has length 3. Okay, xn is some signal. Okay, which may be x1, x2, x3. It has total length of 3. It will have 3 such samples. And impulse response hn has length 5. Okay, so hn, will have some values like h1, h2, h3, h4, h5, right? Something like this. Okay, this is hn. Okay, this is what is hn. So what can be summation xn? Okay, what can be summation of xn? Now what they are telling is modulus of xn, the magnitude of xn is less than equal to b. Okay, for all n. So what can be the maximum summation? Maximum summation means, see what I repeat, the every value of xn, the magnitude of every value of xn less than equal to b. Let us assume that every value itself is maximum so that you maximize the sum. The sum will be maximum if every value is maximum. So maximum summation will be if I assume x1 also as b, because every value less than equal to b, the upper side is b. Okay, the upper side is b. Okay, the other one also b and the other one also b, and it becomes 3b. Okay, same story for hn. Okay, what is the maximum sum? What is the maximum summation? All of them you assume to be now mod hn less than equal to L. So maximum value of any sample of impulse response will be L. I assume all of them as maxima L. So this is 5L. Okay, so if summation xn is maximum, it will take the value 3b. Summation hn maximum will take the value 5L, and the total answer is 15LB. Okay, 15LB, option number A. If 15LB, option number A. Correct answer. 15LB is the correct answer, option number A. Done, dear? A good question. Okay, let's move ahead to the next question. Got it? Yes. For an energy signal ft and its time shifted version ft minus 2, ft minus t, which of the options are correct? Which of the options are correct? Okay, it's about the amplitude spectrum and phase spectrum. Which of them is identical? Which of them is not identical? Okay, so see, spectrum means, let me convert the into the frequency domain. Ft has some Fourier transform f omega, and that f omega can be broken into magnitude spectrum mod f omega e power j angle f omega, right? Now, what is next given to you? There is another signal, suppose ft minus tau or ft minus capital T. Capital T is the amount of time shift. Time shift brings only a phase term, an exponential term. Okay, this is the exact property. Let me write down. So this is equal to f omega e power minus j omega t, right? F of omega e power minus j omega t. Ashutosh says how summation will be 3b. Have a look into this. Now, I'm not telling summation is 3b. I'm telling the maximum value of the summation, Ashutosh. Okay, I'll just complete this question and come back. Okay, let me finish this. So now, what is the net result? F omega, again you write down as mod f omega e power j angle f omega. This is whole multiplied by the exponential term e power minus j omega t. So the net Fourier transform mod f omega e power j, the exponentials you combine. Okay, so angle f omega minus omega t. Okay, angle f omega minus omega t. Okay, right? So now dear, if I say that there is another signal, okay, if I say that this another signal gt is f of t minus capital T, this has some Fourier transform g omega. Okay, that is equal to mod g omega e power j angle g omega. But look into the result now. What is mod g omega? Mod f omega. Okay, and what is angle g omega? What is angle g omega? So the angle part is angle of f omega minus omega t. Okay, so with respect to f, the magnitude spectrum is same. Okay, phase spectrum are different. Option number B. Yes, Ashutosh and Shaurya, correct answer. Neil, correct answer. Okay, B is the correct answer, right? So, this is to explain, you have derived it, but you can simply, if your properties and fundas are clear, you can simply say that, okay, it's a time shift, and we know that time shift only brings a phase term in the frequency form. Okay, so that means only phase part is affected, the magnitude part is same. You can simply comment and go ahead for the next question. Okay, amplitude spectra are same, but phase spectra are different. Amplitude spectra are same, but the phase spectra are different. Okay. Okay, let's move ahead to the next question. Yes, Shaurya, we'll plan for other subjects also. Next question. A signal xt equal to cos 10t cos 100t is passed through a system whose impulse response is given to you. H omega is exponential. What is h omega? Let me write down this h omega separately. This h omega is exponential, that is e raised to the power minus j. Okay, let me take the minus j also common. So it will be 100 and minus j outside, so plus twice of omega minus 100. Or let me simplify this h omega, and it is only e power minus j. It should be simplified as 2 omega minus 200 plus 100 to 2 omega minus 100. E power minus j 2 omega minus 100. Correct? This is what it is. This is what it is. Now, this is a good question. This is a good question. Some decent calculations here will come into action. Okay. Now, okay, this is h omega, right? Now, what is modulus h omega? Modulus, because it's an exponential term, modulus h omega is 1. Okay, and angle h omega, it's only a phase term basically, and the angle part is e power j angle x omega. The angle part is minus of 2 omega minus 100. Okay, minus of 2 omega minus 100, or you can write it reverse as well. It is 100 minus 2 omega. This is what is the phase part given. Why I want the magnitude and phase? Because the input is sinusoidal given. Okay, but product of two sinusoidal terms. Okay, we know what is the response of LTI systems to sinusoids. Okay, so see, first of all, actually I should have a single sinusoid term. Okay, and it is given as the product of cos 10t cos 100t. Some basic manipulation will come up here. Cos 10t, cos 100t, and that is equal to 1 by 2 cos A cos B. Okay, so cos A plus B, half of cos A plus B. So A plus B will give you 110. Okay, plus cos A minus B. So A minus B will give you minus 90 or plus 90. Cos minus theta or cos theta is same. So this is what I will write down. Okay. Now I have two different sinusoids. Now dear, important point is whenever there is an input of the form A cos omega naught t applied to the system, what is the output of the system? Okay, the response to sinusoids on the fundamental formula, okay, it is given by the amplitude of the sinusoid is multiplied by the amplitude of the system, magnitude of the system at the omega naught, at the frequency of the sinusoid. Okay, and the phase part is added with the phase of the sinusoid, that is omega naught t plus angle of h omega naught. Angle of h omega naught, correct? This is what the answer should be. Okay, but what we know, yes, based on eigenfunction theory also, right? So what is mod of h omega naught? That is 1. Any frequency you take, mod of h omega naught anyways is 1 here. Okay, this is anyways 1 here. Okay, so now 1 by 1 if I take, the first input is, let's say, cos 100t, 110t. Okay, here the input, the amplitude of the cosine is also 1. So for cos 110t, okay, mod h is anyways 1, so amplitude will remain same. Okay, it will be cos 110t, cos 110t plus angle h omega naught. So what is going to be the phase? The phase is given by 100 minus 2 omega. Okay, the phase is given by 100 minus 2 omega. What is the omega? Omega is 110. Okay, so this part is cos of 110t, 100 minus 220, so minus of 120. Okay, then there is the another sinusoid with the frequency 90. So cos 90t, this should have how much of the output? Cos of 90t plus 100 minus 2 omega, omega being 90 here. So 100 minus 180. So this part is cos of 90t plus of 20. Sorry, minus of 80. It's 100 minus 180. Sorry. So this has to be minus of 80. Correct me if there is any calculation stuff here. Okay, this is what I have got. Okay. Now we have to, if these are the two inputs added, as per linearity, the outputs will also be added. So what should be the final output? Okay, what should be the final output? Just a second. Okay, what should be the final output? Okay, so let me write down here once again. The input is 1 by 2 cos of 110t plus cos of 90t. So correspondingly output will be 1 by 2 cos of 110t minus 120 and cos of 90t minus 80. Both the outputs I have added up, and it's about rearranging the question now. We'll have to have slight rearrangement. So what is that slight rearrangement? We will see that. The options are also given in the product of cosine functions. Okay, so I'll have to think about cos A plus B plus cos A minus B. Angles are not exactly same here. Okay, so what should I be able to break this as? Cos 110t, first break it as 100t plus 10t. Here also 100t minus 10t, and the center point of this is 100. Okay, so let me write this way. Just keep note looking. 100t minus 100 plus 10t separate and minus 20 separate. Is it okay? This is 110 and this is 120. Now next one I should write it as 100t minus 10t. Okay, and 100t minus 100. If I take minus 100 here, okay, first of all, this is minus 10t and this should be plus 20. See now, minus 100 plus 20 minus 80 and 100 minus 10, 90t will come. Okay, looks good. Okay, looks good. Okay, looks good. Okay. So what is the yt? What is going to be the yt? Okay, it is equal to 1 by 2. It is equal to 1 by 2. Now see this. Let's call this as A plus B, and then this is A minus. Okay, so for simplification, let me take this minus outside. Okay, if you take minus outside, then it will exactly look the previous case. I'll take minus outside, then you can write it as 10t minus 20, correct? Okay, so this is b, 10t minus 20. The cos a plus b plus cos a minus b. Okay, cos a plus b plus cos a minus b, 2 cos a cos b. Okay, so 2 and 2 would get cancelled actually. 2 and 2 would get cancelled. And the final answer will be, okay, cos a cos b, cos 100t minus 100 multiplied by cos b, that is cos 10t minus 20. Let's match the answers. Oh, the last step, let's take this factors common. So the final output from the first term, let me take the 100 common, so t minus 1 is left. From the next, what can I take common? 10 common, so t minus 2 is left. So 100 t minus 1 cos 10 t minus 2. Okay, option number C. 100 t minus 1, 10 of t minus 2, option number C. Right? Okay. Okay, Karan, I'll check with the office once. Okay, yeah, maybe if for some particular book stock is over, so very soon we'll make you available the new stock, the updated books, because GATE 26 question will also be included, and the new PYQ book will come to you. Okay. Chalo, let's move ahead to the next question. Okay, so this was a good, decent question. The next one is here in front of you. Which one of the following can be the magnitude of the transfer function h of j omega of a causal system? Magnitude of the transfer function. Now see, we have to solve this question logically. Okay, you have to solve this question logically. Although they have given modulus magnitude, the amplitude spectrum, but yeah, if you look into option ABC, the signals, I can call it as band limited. Okay, I can call it as band limited, right? Why? Because if modulus of h omega is 0 after this, the entire h omega will be 0. Right. So if you look into the option A, B, C, what is one thing common? Okay, the signals represented by options A, B, C are band limited in nature. Correct, na? They are band limited in nature. Correct. They are band limited in nature. Okay, whereas now if I talk about D is band unlimited. Okay, now see, what is the problem if they are band limited? Okay, if a signal is band limited, okay, that means if it is limited in the frequency band, it's unlimited in the time domain, right? Na? Okay, you can think with respect to the compression property. You can think also, suppose if you, now for a moment, if you assume it to be h omega only, triangular function. So what is the inverse Fourier transforms? Sampling square, rectangle function, inverse Fourier transform, sampling function, sampling square. Both of them exist from minus infinity to infinity. Okay, so that means all these will be unlimited in time. Okay, and unlimited in time, that means if they are existing from minus infinity to infinity, okay, they cannot be causal, because you want the system to be causal, and if you take it to the time domain, h of t, impulse response should be 0 for t less than 0. It should not go from minus infinity to infinity. Okay, it should not go from minus infinity to infinity. Okay, unlimited in time, normally minus infinity to infinity will be assumed. Okay. Okay, so that is why ABC cannot be causal. Now, because D, see, you don't have to exactly take the inverse Fourier transform. You cannot also, because phase part is not given. Okay, but D is band unlimited. Okay, so that possibility is there. It is going to be limited in time domain. Okay, so option, what happened? Just a second here. This one. So option number D is the possibility for causal. Okay. Which of them can be the magnitude of a causal system? It could be option number D. Let's move ahead to the next case. This. Yes. Okay. Correct answer, Neil, Shaurya. Okay. Fine. So moving ahead. Okay. To the next question in the sequence. Or let me go to. Yeah. Next one. a signal MT, simple one only, band limited to a maximum frequency of 20 kilohertz is sampled at the frequency fs to generate ST. An ideal low pass filter having the cutoff frequency 37 kilohertz is used to reconstruct MT from ST. What is the minimum of fs required to reconstruct MT without distortion? Without distortion means without aliasing. Okay, so that is possible. See, if you recall the spectrum, okay, see what is the sampled signal here is known as ST. Okay, and if you recall the spectrum of a sampled signal, if you recall the spectrum of the sampled signal, how a signal will look like after sampling is done. Okay, so signal is band limited. Okay, I'm drawing S omega here. Okay, the spectrum of ST. Okay, it is band limited up to 20 kilohertz. Okay, so we can assume any waveform like this, minus 20 to 20, where I'm assuming this has the frequency in the kilohertz directly. Okay, and then the next spectrum starts. Next spectrum is shifted by the sampling frequency Fs. Okay, so this will be centered at Fs. So this is going to be Fs plus 20. This will be Fs minus 20, etc. Minus Fs minus 20 minus Fs plus 20. Now, okay, etc. Now, an ideal low pass filter having the cutoff frequency 37K is used to reconstruct MT. Okay, is used to reconstruct MT. Okay, from this ST. Okay, so what is that ideal low pass filter? It has the cutoff frequency 37K. 37K. Ideal rectangular filter. Okay, and you only want to, now this single part is actually m omega, right? This single part is m omega, the Fourier transform of the original signal MT. If you only want m omega, so the possibility is this Fs minus 20 of course should be greater than 20, but not only greater than 20, it should be greater than 37 also. Okay, why? Because the cutoff frequency used is 37. Okay, so if this Fs minus 20 was suppose entered in this region, okay, so then it will also appear in the output. Anything in this bracket will appear in the output of the low pass filter. Okay, so I only want the m omega to come up. Okay, so to reconstruct MT without distortion, the condition would be this Fs minus 20 is greater than 37. Okay, and also greater than 20. But if it is greater than 37, it is greater than 20. That means Fs greater than 57. The units are in kilohertz. Option number C, 57 kilohertz. Simple, fundamental question I will say for sampling. Yes, Neil, correct answer. Shaurya, correct answer. It is option number C. This is option number C. Right. So let's go to the next question. Okay, a continuous time signal has the frequency contained at f equal to 10, 50 and 70 megahertz. The signal is sampled at sampling frequency of 56 megahertz. The sampled signal is then passed through an ideal low pass filter with cutoff frequency 20. The continuous time signal has frequency components only at some discrete frequency. Okay, so we can assume that maybe there is a sinusoid at 10, another at 50, another at 70. Okay, right. Yeah, whole signal means yes, the different variety of the questions of signal. It's a practice session. We are not taking up the theory part, fellow, for today. But yeah, of course, with questions, we are revising some concepts, no doubt. But yeah, entire signals, different variety I am taking. So see dear, we know that the signal is sampled at a sampling frequency Fs56, and we, within one spectrum, the continuous time signal within one spectrum has the three frequency components available. Okay, so the frequency components are 10, okay, 50 and 70. Of course, then it will also be at minus 10, minus 50, minus 70. One way you draw the waveform, let me solve it very simply. We know that it is going to be right shifted like this. It is going to be right shifted by Fs to Fs or minus Fs minus 2Fs, etc. Right and left shifted both. So if you do the right shift by how much? Sampling frequency 56. Okay, so this will go to 66. Okay, Okay, this will go to 106 and this should go to 126. Okay, and also if you left shift this, by 56, that means, minus 56, you reduce from this value, the 10 minus 56 will be minus 46, 50 minus 56 minus 6, 70 minus 56 will be going to be 14. The same activity I will be doing here as well. If you do plus 56 here, okay, plus 56 here will give you 46, will give you 6 and will give you minus 14. We know that symmetry anyways will be maintained. Okay, and then if you reduce 56 here, so this is minus 66, minus 106 and minus 126 and etc. plus one more 56, minus one more 56, like that. But the sample signal is then passed through the low pass filter whose cutoff frequency is only 20. Okay, so even if you now apply plus 56 one more time, no need, na? Okay, the values will be higher only. Ultimately, only the frequency components less than 20 will be saved out. So what are the frequency components less than 20 that will be saved out? Is a 10, okay, is a 10, is a 14 and is a 6. Okay, 10, 14, 6, option number C. Correct, na? Option number C. Option number C. Right? Option number C. Okay, fine. Let's move ahead to the next question. Okay, yeah, simple one. Let's come to this one. Simple one. A simple question indeed. Okay. Right. One of the very simple, I can say, the Laplace transform of the signal, a rectangular pulse given to you. Okay, a rectangular pulse, let's say this signal is xt. Okay, and the amplitude is a, and the rectangle starts from origin. That means it can be represented, it starts from origin, ends at some point c. So it should be, any rectangle can be represented as subtraction of two step signals. Okay, it will start from ut, it will start from origin ut, and another step signal should be there at t equal to c. So we subtract u of t minus c. ut minus c will give you a rectangle from 0 to c, and amplitude a, so I have multiplied, I've scaled it by a. Okay, so what is the Laplace transform finally? A, step Laplace transform 1 by s. Again, unit step Laplace transform 1 by s, but time shifting property will give you e power minus sc. Okay, so this is equal to eventually a by s 1 minus e power minus sc. A by s 1 minus e power minus sc. Okay, next question then. Okay, consider the compound system shown in the below figure. Its output is equal to the input with a delay of 2 units. Okay, with the delay of 2 units. If the transfer function of the first system is given by h1z equal to z minus 0.5 upon z minus 0.8, okay, then what is the h2z? See here, it's again a simple concept, property based question, I would say. Okay, so there is a compound means cascaded here. Its output is equal to input with the delay. So talk about this one, output. Let's say output is yn, okay, and input is xn. So what they mention in the theory that the output is equal to input with a delay of 2 units. So that means the input output relation you can mention as x of n minus 2, simple. You can mention the input output relation as yn equal to x of n minus 2, correct na? Yn will be equal to the x of n minus 2. Yn will be equal to x of n minus 2, correct? Okay, x of n minus 2. Next, okay, now if yn is x of n minus 2, what's going to be the overall transfer function of the system? Okay, let's convert to the z domain. Okay, so y and z transform yz equal to x and z transform xz, and you know x of n minus 2, time shifting property, z power minus n naught to x of n minus 2, z power minus 2 should be multiplied here. Okay, so what is the transfer function h of z? Let's say the complete system has some transfer function xz, and that complete transfer function, let me write it here, that complete transfer function is product of these two because they are connected in cascade. Whenever systems are in cascade, their gain or transfer function will be multiplied, right? Okay, and by the input output relation, the transfer function, which is written as yz upon xz, is z power minus 2. Okay, so now the problem is almost solved. Okay, because h1z is given to you. Okay, h of z, which is h1z multiplied by h2z should be equal to z power minus 2. Okay, so what is the h1z given to me? Z minus 0.5 divided by z minus 0.8 multiplied by h2z is equal to z power minus 2. So what is the value of h2z? It is z minus 0.8 upon z minus 0.5 whole multiplied by z power minus 2. So I think they have taken inside and also taken in the negative powers of z even. Okay, the first let me convert to negative power of z, dividing this expression throughout by z. So 1 minus 0.8 z inverse, 1 minus 0.5 z inverse. Further you multiply z power minus 2 inside, so z power minus 2 minus 0.8 z power minus 3 upon 1 minus 0.5 z power minus 1. Option number B. Correct, dear? Option number B. Fundamental on the properties. I'll say this is a fundamental question on the property. Right. Okay, so then let's move ahead to the next question. The next question, here it is. The z transform xz of a sequence xn is given by, okay, z power 20 upon z minus half, z minus 2, z plus 3, and if xz converges for mod z equal to 1, some ROC, some information about ROC would be given here, then what is the value of x minus 18? What is the value of x minus 18? Let's work it out, dear. Okay, xz is z power 20. See, first of all, to solve it, I think you should break into partial fraction, and to break into partial fraction, take z power 19 separate and 1z you leave it here, z upon z minus, or forget, let's take the total only, z power 20 outside and break this term, easy, break this term into partial fraction. Okay, z 1 upon z minus half, z minus 2, z plus 3. And then this should be 1 upon z minus half, 1, sorry, why I'm writing 1, it should be some number a, b, c, or let me solve this partial fraction here actually separately. Okay, so what will I have? I have 1 upon z minus of half, z minus of 2, z plus of 3. Suppose in the partial fraction it is broken as a upon z minus half, b upon z minus 2, c upon z plus 3. Okay, yeah. So let's move forward with this. Okay, so now what is ABC? So to calculate A, I will multiply, first let me multiply z minus half, z minus 2, z plus 3 throughout. Okay, so this is equal to, okay, or let me calculate the partial fraction number directly. Okay, what will be A equal to? You can calculate the partial fraction numbers also by the residue method, na? Okay, so it should be equal to z tending z minus half cancelled, 1 upon 1 by 2 minus 2, 1 by 2 plus 3. So this is equal to 1 by 2 minus 2 will be how much? Minus 3 by 2, and this one will be 3 plus 2, 7 by 2. So this is going to be minus 4 by 21. Okay, check the values. I think this is going to be correct. 1 minus 3. Yeah, this is minus 4 by 21. B value, again by the residue method, okay, will be 1 upon 2 minus half, that is 3 by 2, and 2 plus 3, which is 5. So this looks like 2 by 15. Okay, and C value will be, okay, minus 3 will be substituted. So minus 3 minus half will be minus of 7 by 2, and minus 3 minus 2 minus 5 minus minus plus only, so 2 by 35. Okay, so what is the final value of xz? Okay, now see, now I will use the z power 20, and one z I will send inside with these numbers ABC. Okay, so outside I will only leave z power 19, and z power 1 I will send inside, and that inside a value is minus 4 by 21. So first is minus 4 by 21 into z upon z minus half. Next is 2 by 15. Okay, so plus of 2 by 15 z upon z minus 2, and next one I have got as 2 by 35. So plus 2 by 35 z upon z plus 3. Z upon z plus 3. Correct, dear? Okay. So now, what is this xz? What is this xz? Or let's take the inverse. Remember, let's take the inverse z transform. But if you talk about the pole, mod z equal to, the pole is z equal to half, z equal to 2, z equal to minus 3, right? And what they are telling, the xz converges for mod z equal to 1. Okay, that means unit circle should be included. Okay, unit circle should be included. So what is the ROC? Okay, mod z equal to 1 included. Okay, so what should be the ROC? Okay, ROC should be then mod z greater than half but less than 2. Okay, 1 by 2 less than mod z less than 2. Okay, that is what the ROC. It should be greater than half because 1 has to come, but it should be less than 2. Okay, you cannot directly take less than 3 because if you take less than 3, 2 will come inside and the pole inside. ROC is not allowed. Okay, right? ROC is not mod z equal to 1. ROC will have mod z equal to 1 included. So we have to frame the ROC like that, fellow. Okay, so what is the signal xn then? Okay, accordingly, what is the signal xn? See, z power 19 we will consider, no doubt, but first look into this z upon z minus half. So see, remember two fundamental formulas. Okay, remember the two fundamental formulas. Let me write it here. You have z upon z minus a. What is the answer you will write for z upon z minus a? Or better, let me revise the formula here. Okay, let me revise the formula here. So remember, okay, there are two formulas, a power n un. A power n un will have the z transform z upon z minus a with the ROC mod z greater than, exterior ROC greater than mod a. For a power n u minus n minus 1, then the z transform is minus z upon z minus a. Okay, same formula, only is minus difference, but ROC mod z less than mod a. So, with respect to the first pole, first a mod z greater, mod z is greater than half. Okay, so what is the formula to be applied? 1 by 2 power n. 1 by 2 power n un. I'm just looking into this factor still. I'm just waiting for this factor. Or what will I do is, see, this is not xn. What will I do is, I'm just writing the inverse z transform. Last step I will apply time shifting. Okay, just I want to explain you step by step. Okay, so inverse z transform of only this much of the part. Okay, so minus 4 by 21 half power n un. Next. So now with respect to mod z is on lesser side. So final formula should be, it will come up as minus because we need, here minus you want, you can shift to the left side. Okay, so minus of 2 by 15 and a is 2. So 2 power n u of minus n minus 1. Okay, the left sided formula. And then the third case, again mod z is less than 3 also. Okay, less than 3 also. So again the left side formula, minus 2 by 35, a is minus 3 power n u minus n minus 1. Correct. Now this is the inverse z transform of only this much part, but the actual z transform is multiplied by z power 19, and z power 19 again means time shifting property. Z power 19 again means time shifting property. So what is the actual xn? Dear, the actual xn minus 4 by 21. minus 4 by 21 half power n plus 19 u of n plus 19. Okay, z power plus 19. The time shifting will be applied. Okay, time shifting will be applied, right? Okay, minus 2 by 15. Okay, 2 power n plus 19 u of, now if you write down here, minus of n plus 19 minus 1, if I write down n as n plus 19 here also, then the final answer will be minus n minus 19 minus 1. So minus n minus 20 it will become, correct? Okay, minus n minus 20, and same for the last term, that is minus 2 by 35 minus 3 power n plus 19 u of minus n minus 20. Okay, now what I want, the question is asking x minus 18. Okay, what is the value of x minus 18? See, x minus 18. Now be careful, when you put minus 18, here unit step, inside the unit step bracket, still positive value is left. Okay, here minus 18 minus 20 negative, inside a unit step bracket, if you enter negative time, the value is 0. Unit step is only defined for positive, n equal to n greater than equal to 0. If it is un, I mean whatever is the bracket, it should be positive value. Similarly here minus 18 minus 20 negative, so these two parts will be 0. This unit step will be 1. So answer only first term, minus 4 by 21. Okay, 1 by 2 raised to the power minus 18 plus 19 into 1. Rest both will be zeros. Okay, because unit step does not exist there. So minus 4 by 21 and half power 1. Okay, so this 2 cancels, minus 2 by 21. Minus 2 by 21, option number B. Good question. Okay, good question. Minus 2 by 21 is the correct answer. Yes, correct, Abhishek. That the musical chair mostly will go to MTA only. That musical chair will mostly go to MTA. But yeah, if a question is taking long amount of time, you should not spend that much of time. I mean, 30 minutes is big, but yeah, sometimes it happens in exam. I mean, that's really IIT should think about. But student, you also should be careful. Don't spend time, but don't spend a lot of time also. Okay. So 39 in EC, you can end up with some, good NITs, but IITs, especially good IITs will be tough there. Okay, next question, dear. Right. So the Z transform XZ of a real and right-sided sequence Xn has exactly 2 poles. Okay, has exactly 2 poles. And one of them is at Z equal to e power j pi by 2, and there are 2 other zeros at the origin. If x1 is 1, which of the following is true? If x1 is 1, which of the following is true? If x1 is 1, okay, now the signal is also given to you as a real and right-sided sequence Xn. It has 2 poles. It has 2 poles, and one of them is at Z equal to e power j pi by 2. E power j pi by 2. And there are 2 zeros at origin. And there are 2 zeros at origin. Okay, now there are 2 poles, right? And one of them is at, see, first of all, what is the property of a real sequence? If there is a real signal, if there is any real signal, okay, and if it has complex pole, I don't say it should have complex pole, but yes, if it has complex poles will if any, will occur in the conjugate pair only. Will occur in the conjugate pair only. Okay, that means if there is a pole at Z equal to e power j pi by 2, Z equal to e power j pi by 2, which is nothing but equal to j cos pi by 2 plus j sin pi by 2, which will be j only. So there will be another pole, okay, there will be another pole which is conjugate, because it's a complex number, it will be having a conjugate pole as well. Okay, so now on the basis of this information, what is my Z transform XZ? I need an information on the Z transform XZ. Okay, and that will be, it has 2 zeros at origin, so numerator should have Z square, maybe some constant gain term, and denominator should have these factors, Z plus j, Z minus j. Okay, that means this is of the form kz square upon z square minus j square, but j square is minus 1. So z square upon z square plus 1. Okay. So, you are left with option number B or D. Now, you can conclude on the basis of ROC itself. See, the pole, the magnitude of poles, you can directly conclude here. Okay, the magnitude of the pole for both of them, okay, both have mod z equal to 1. Mod of j, mod of minus j is 1. So, what should be the ROC? Okay, ROC, right-sided sequence. Right-sided sequence. So, mod z should be greater than 1. Mod z greater than 1. Okay, so when you combine these two, it's not necessary to find the value of k, but the combination of these two function is z square upon z square plus 1, ROC mod z greater than 1, not greater than half. Option number D is confirmed here. Option number D is confirmed here by the combination of these two. By the combination of these two, correct? Option number D. Still, if you want to find k, for that reason they have given x1. For that reason they have given x1. See, if you take x1 equal to 1, okay, x1 equal to 1, that means k into 1 upon 1 plus 1 equal to 1, giving you k equal to 2 as well. See, here it is k equal to 2, but that is not a required calculation, right? Yes, fellow. I mean, that is unfortunate event, and you should not, because even I believe, no, NAT does not mean you have to write exact answer, even approximation work. But let's see, there are two things NAT. One thing is, they mentioned round off to the nearest integer. Okay, so we can't 100% blame them also. The question, I think, clearly mentions round off to the nearest integer. But the point is, why, even I agree on you, why they are testing the student for rounding off? I mean, if a student knows that directional derivative, okay, he knows the calculation of directional derivative, gradient and all, and if you have got the correct calculation, you deserve the mark. You deserve the mark. So that is unfair. I mean, we cannot call the question as wrong because they mentioned round off to nearest integer, but that's a sad story. Even I'm not convinced. IITs, you are not going to test students for rounding off. You should test the students for concept, for their heart, for their preparation. Why you are testing the students for rounding off and all those things, especially in, so that's unfortunate. I mean, what is the thought process of the examiner? Sometimes difficult to understand. You can challenge it, but very less chances it would be accepted. Okay, very less chances it would be accepted. I mean, ideally they should accept, but they will not work on ideal condition. Na? For them also, giving them, changing the answer key is a matter of their, respect or ego, whatever I call it. But yeah, that's a 2-mark simple question. Many students lost those easy free 2 marks. It's like that actually. It's actually that way. Okay. Chalo dear, next question. So consider Rn summation m equal to 0 to n minus 1 ym xm minus n. Okay, where yn and xn are real periodic signals with period n. The above output can be obtained using basic property and manipulation of the formula. Look into that. Look into that. Okay, let's go to this solving this. Okay, so what is Rn given to you? Summation ym x of m minus n. Okay, So you understand this like this. It is summation m as 0 to n minus 1 y of m. Okay, see, first of all, forget this. Okay, forget this. If I ask you to write down it because it gives me a hint about convolution formula, summation xm h of n minus h y of m minus n or x of m minus n. Okay, so if I actually ask you, there is one signal yn and there is another signal xn, and if I want to write down the convolution formula, circular convolution, because they are periodic, real periodic signals. So if I want to write down their circular convolution formula, if I actually want to write down their circular convolution formula, what it should be? Okay, it should be actually given by yn circular convolution, only xn I am taking, summation of yk or ym. Here the summation parameter m doesn't matter. Summation ym, like summation yk x of n minus k, so x of n minus m. Okay, m equal to 0 to n minus 1. This is what is the circular convolution formula. Clear? Right. Now, x of n minus m. X of n minus m. But here it is x of m minus n. So, dear, similarly, if I ask you, what should be the circular convolution formula between yn and x of minus n? It should be summation 0 to n minus 1 y of m x of minus n. Okay, so n is replaced by n minus m. Okay, and then it looks like summation ym x of minus n of minus m, so it becomes x of m minus n. Then you will get the above formula. Correct? Okay, correct. So that means this given formula suggests me that the R of n is actually the circular convolution of yn with x of minus n actually. With x of minus n actually. Okay. X of minus n. Yes, trending will try to plan that. Okay. Yn circular convolution x of minus n. Right? Okay. Time scaling will see, I'm not going to convolute here because fellow, the point is in circular convolution. Okay, see, what I want to say here is, see, if there is xn convolution yn as some signal zn, and if you want to apply time scaling, xn circular convolution x minus n convolution y minus n will be z minus n. Time scaling property can be applied if both are scaled. I am not using any time scaling property. I am not calling this as r of minus n or something. I am just manipulating the summation formula, and I am saying you that this is some convolution formula between yn and x of minus n. Okay. Now, then what, convert to DFT. Okay, so let us solve it here. Okay, so there is some signal Rn given, which I have manipulated as y of n circular convolution x of minus n, taking the DFTs on all the sides. R of k should be equal to, now convolution in time, multiplication in frequency, multiplication. Now, if xn has the DFT xk, x minus n has the DFT x minus k. X minus n has the DFT x minus k. Okay, scaling in time is scaling in frequency. Sorry. Folding in time is folding in frequency, right? Okay, so yk x of minus k, rk is yk x of minus k. Correct, na? Rk is y of k x of minus k. Okay. Now, dear, what the signal can be? Okay, what the signal can be derived as or can be obtained as? That means the R of n. This is the DFT now of Rn. Okay, so R of n means IDFT of what? It is the IDFT of Rk. That means it is the IDFT of yk x minus k. Okay. It is the IDFT of yk x minus k. Okay. Yk means DFT of yn, and x minus k means, okay, DFT of minus x. Correct. Okay. DFT of minus x, no. DFT of minus of DFT of, just a second. X of DFT of minus x, no. Then, actually, then there is a typo error, dear. This option is actually plus only. This option is plus then, because we'll use the real signal property now. Okay, because if a signal is real, see, what I have taken is xn, number one has the DFT xk. Okay, x minus n has the DFT x minus k. That is what I used. But signal xn is real. Okay, if a signal is real, the DFT is said to be what? DFT is said to be conjugate symmetric. DFT is conjugate symmetry. Okay, conjugate symmetry means the x of minus k, DFT for negative k, is equal to the Fourier transform of positive k by taking the conjugate. So xk conjugate, that means this can be further written as y of k x conjugate k, and then I can say that this Rn is IDFT of y of k into x conjugate k, conjugate of x. Okay, conjugate of the DFT x. Correct. Option number A then will match. Okay, right? Because this says DFT minus x. No, it's not minus x of minus k. That is time scaling, not amplitude scaling. Okay, good to know that trending video. Yes, if you have not prepared till now, Abhishek, yes, you can skip, because as I've told you earlier also, in BARC exam, 100 questions are there in 120 minutes. Okay, that clearly tells you, and not all questions are easy. Some questions are good. Like today, I have taken intentionally some good questions of signals. Okay, so not all questions are easy. There are good questions also. That means you will not be able to attempt all questions. Okay, so even if you, if you have not prepared and if you now leave a topic, that's okay, because anyways, 1 week of time is left. So don't, go into unnecessary stuff right now. Okay, dear? That is how it looks like. That is how it will look like. Then, dear, so this was a decent question on basic DFT, IDFT property. Dear, once again, an important reminder that for all the OHM online courses, okay, the OHM brings to you the scholarship test, the online scholarship test for EE and EC branches. Okay, for GATE 26 and GATE 27 courses, where this scholarship test is going to be conducted on 23rd of March 2025, evening time 6:30 p.m. to 7:20 p.m. Evening time 6:30 p.m. to 7:20 p.m. The syllabus for EC and EE fundamental subjects we have taken, respectively mentioned, and if you perform and if you are in the top 3, you get flat 100% scholarship. If you are in the rank 4 to 10, 50% scholarship, and etc. Based on your performance, you have, the scholarships to be offered. Right, guys, so this test will be conducted, you can take the test on the Online Plus app as well, OHM Online Plus app as well, or you can take it on the website, okay, in the browser mode, that is ohminstitute.in. Okay, there will be 10 questions of 1 mark, 10 questions of 2 marks, right? And also, guys, if you want to register, that test is also free, and even you can, but before you appear to the test, you have to register. Registration is also free, and the registration link has been attached in the description of the video. You can go and directly register there. Go and directly register there. Now, guys, next big announcement, the next GATE offline batch, okay, for GATE 26, okay, starts 9th of March. Okay, starts 9th of March. That is next Sunday. Okay, 9th of March, the next offline batch is going to start. The fee currently is priced at 54,999. And for any queries for any of the batches, offline or online batches, you can contact 9515694053. Okay, dear. And the next offline batch for AE exams, okay, targeting TG Transco Discoms or AP Transco and Discoms, okay, starts March 7th. Okay, this is going to start March of 7th. All right, that's it, guys. And like the other sessions, I'll share you the PDF. Of course, my PDFs are password protected. The password will be DFT. Last question was based on DFT. So password that I'll keep for this particular PDF is going to be DFT. Okay, you will get the password. You will get, sorry, not the password. Password I've told you right now. You will get the PDF in my Telegram group, which will have this password protection. So you can note down so that you remember it is DFT, everything in small. Everything in small, and you will get it in the Telegram link if you are already connected well, or you can directly join using this name mentioned, right? Okay, dear, done. Bye bye, thank you, stay safe, all the very best for BARC exams, and we'll plan more sessions.